So in this example, I have the exponential function x of t, which is same as before, and the h of tau is an impulse. So the first step is to change the axes, t to tau for x of t and t to minus tau for h of t. So I have this is from 1 to 3, x of tau, which is tau axis, and the impulse will come at minus 2, and the reference point will be this. The shift on this side, left side is minus t, and on right side is plus t. So but in this case I have the only shift is in this direction. So the case one will be the case of no overlap. So I have my x of t here, 1, 2 and 3, and this is my, so it is just at the edge. My reference is minus 2, so this shift is from minus 2 to 1, which is 3. So if the time is less than 3, the shift is less than 3, there will be no overlap, and y of t will be equal to h of t minus tau x of tau d tau, that will be equal to 0. And the next case is when I move inside. So I move inside, I am more than t but less than, uh, so this is 1 to 3 and I am inside. This is my x point, this is my reference, and the end of this case is when I am completely outside. So 1, 3, and this is where I am. This is my reference. So this is 5. So at t equal to 5, I am outside. So this case will go from 3 to 5. So my y of t will be just the integral of with the impulse, which is at x d tau. Now, to evaluate this integral, we use a property called shifting property, which is a very simple property, and we can evaluate all the integrals with the delta function. So this property says that whenever I integrate a function with a delta function, which is at a point A within that function, so the answer is just the value of the function at the point A. So there is only one answer, one point, which is the value of the function at that point. So in this case, I will just replace tau with x. So y of t will be equal to e raised to minus tau minus 1 delta tau minus x d tau. So applying the same rule, it will be f of x, and f is this exponential, so it will be e raised to the power minus x minus 1. Now x is, again, we can just evaluate it using this diagram. So x plus 2 equal to t, so x equal to t minus 2. So then this will be just e raised to minus t minus 2 minus 1, so t minus 3. So now I can write all my y of t is equal to 0 for t is less than equal to 0, y of t is equal to e raised to the power minus t minus 3 for 3 between 3 and 5, and the last case is case 3 when t is greater than 5. So, and this is after that, so t is greater than equal to 5, y of t equal to 0 because no overlap. So y of t in summary is 0 for t is greater than 5. Now what is my y of t? Y of t is just the same function but shifted to 3. So y of t is, I will just draw it here. Yeah, this is my y of t. I will just draw it here. So the final y of t will be So e raised to minus t minus 3. So this is my final answer.